That lab that we took a look at in terms of gravity and orbits of planets, satellites around stars or satellites around Earth, we saw that those objects are moving in a circular path. Okay, really, obviously, we know that the path of the Earth around the Sun isn't perfectly circular. However, for our purposes, we're going to say it was, or we're going to say that it is. Okay, so what you should have seen in that PhET sim was that at any point along that circular path, the Earth had some velocity vector that was pointing in a direction similar to this. So at any point along here, that velocity vector was constantly changing direction. Okay, but the magnitude was the same. Okay, now what we call this velocity, we call this tangential velocity. Okay, and we can designate that on here as VT, and I'm going to put my little vector symbol over the top. Okay, now what tangential velocity is it's just the velocity that this object has on a tangent line according to that circle. Okay, so at any point along here, that velocity vector is changing, but it's always going to be tangent to that circular path. Now, what was actually causing this tangential velocity? What was causing that, well, in our case, what was causing the planet Earth to actually move in a circular shape around the sun? Well, you should have noticed that we had that force of gravity, from the sun acting on the Earth, pulling the Earth in that circular pattern. Now notice here that, well, this picture's a little skewed, but notice that all of these force vectors point directly to the center of that circle. Okay, they point directly to the center of that circle. And forces that are directed towards the center of a circle we call centripetal forces. Okay, centripetal forces. And we can break this word down so you can understand it a little bit more. Centra meaning center, and pedal meaning seeking. Okay, so these forces are center-seeking forces. Okay, they're pointed to the center of the circle, and they allow that object to then essentially to feel like they're being pulled towards the center of that circle. Now, a really important thing that we need to know here is that I'm going to denote centripetal forces as FC. Centripetal forces can be considered net forces. Okay, so that has some big implications for us. So we can say, like sum of forces is equal to MA. Well, we can then say that centripetal force is equal to mass times acceleration. Well, we know that acceleration has to be in the direction of our net force, so that means then that our centripetal force is equal to mass times some centripetal acceleration. Now, when we think about acceleration, we think about, well, there's two things that we can think about. You can have acceleration through an object changing its velocity, or you could have acceleration based on an object changing its direction. Now, we should have seen then in that PhET that our velocity was constant. The velocity of the Earth moving around the sun was constant. So the centripetal acceleration in this case does not change the value of the velocity. However, notice all along here, the direction of our velocity changes. So centripetal acceleration then is, it's still the rate at which tangential velocity changes However, we need to make sure that we know that the centripetal acceleration is changing the direction of that tangential velocity. Okay, now how do we actually determine what centripetal acceleration is? And there's a quick exercise that we can do here. So say that I have a circle and it has some radius r, and I have an object moving along that circle with some tangential velocity, okay? And then obviously I have my centripetal force actually keeping it on that circular path, essentially pulling that object towards the center, pulling it around in that circular path. So when we think about acceleration, well, we think that acceleration is the change in velocity over time. Well, we don't know anything about time in this scenario. However, let's just think about the stuff that we do have here. So we have tangential velocity, and when we think about the units for velocity, we think about meters per second. And then we also know a radius here. Well, when we think of radius, we should think here about meters. And then if we're thinking about acceleration, our acceleration units we've always used as meters per second squared. So how in the world do we use these two to get to this? Well, we can do a little thing called dimensional analysis here, and I would encourage you to pause the video right now and maybe try this out, see how you can manipulate these two things to get into these two units. But because we need to get these meters per second squared, what we need to do is we would have to square this term, right? Because we need to get seconds squared. So what we could do then is we could say that centripetal acceleration is equal to tangential velocity squared. However, that's going to give us meters squared per second squared. However, we know that radius is typically in meters, so then we can divide our tangential velocity by r. So that's going to give us then our units of meters per second squared. Now, this circular motion thing is kind of difficult to think about. I think we're very used to working in straight lines. I mean, just think back to Newton's first law. Objects want to keep doing what they're already doing. They want to keep moving at that constant speed, or they want to stay at rest. You should have seen in that PhET lab that as soon as you turned off that force of gravity that was pulling that planet to the center, well, that object wanted to keep moving in a straight line based off of the direction of that tangential velocity vector the instant that gravity was shut off. So big takeaways here in circular motion is that because of that force of gravity, because of any centripetal force, that force is actually changing the motion of that object. At any instant in time, it's changing it because it's always directed towards the center. Okay? So, again, big takeaways here. Centripetal force is always directed towards the center, and it causes a centripetal acceleration, which, again, is also pointed towards the center, and that's constantly changing the direction of an object in circular motion. Okay, so we're going to be applying circular motion concepts throughout the next few days. Take care, AP Physics students.